So, oops, there are times when du dx is not a perfect match. So in that case, what do we end up having to do? So um, I'm going to start by just going through what I would think is my u. So looking at this, I have that u would be probably this inner function. So u equals x squared plus 1, which would mean that du equals 2x dx. And you will notice that the 2x is not there. So I need to multiply. I need to get this in there because I don't have the 2. So I am going to multiply top and bottom by 2. Okay. Now with an integral symbol, a variable cannot get outside the integral symbol. But a number is kind of small enough to fit through the integral symbol. So I'm going to take this and I'm going to squish him through there, okay? And that should allow us it should come out the same. So I'm going to rewrite this. So I've got 1/2 the integral of the 2x, because I pushed the 2 inside, and then the x squared plus 1 d to the 6th dx. Now I have my u substitution ready to go. So I have 1/2 the integral. I'm going to put u in for the x squared, or the x squared plus 1 to the 6th. And then for the 2x dx, I'm substituting in du. So we end up with 1/2 u to the 7th power divided by 7 plus c. So this is the same as 1/14 u to the 7th plus c. Now I'm going to substitute my u back in, which would give me 1/14 x squared plus 1 the 7th plus c. All right, let's look at b. So I've got my u as 2x plus 1, meaning that my du equals 2 dx. I see the dx, but I'm missing the 2. So I'm going to multiply by 2/2, and I'm going to take that 2 and I'm going to squish it into the inside. I'm going to let it go through the integral symbol. So we have 1/2 the integral of 2 square root of the 2x plus 1 dx. Now I have my u and my entire du, so I'm ready to integrate almost. I'm going to go one more step here. So we have 1/2 the integral of 2. I'm going to switch this to the 1/2 power. What's going on? Let's convert it to u sub first, then I'll switch it to the 1/2 power. Square root of my u, I'm just going to substitute u in. And then I'm going to, for the 2 dx, I'm substituting in du. We have 1/2 the integral of u to the 1/2 du. I am going to add 2 over 2. So we end up with u to the 3/2 divided by 3/2 or multiplied by 2/3 plus c. I'm noticing that my 2's cancel. So I end up with 1/3 u to the 3/2 plus c. So I'm going to go ahead and substitute my u back in. So my u ends up being 1/3 times 2x plus 1 to the 3/2 plus c. Right, let's do part c here. So my u that I'm looking for, I remember I'm looking for an inside function for u, so it's probably this. So let's try that. So u equals 4x cubed minus 5. So let's see what happens with du. So du equals 12x squared dx. I see the x squared, I don't see the 12. So I'm going to multiply top and bottom by 12 over 12. All right, so let's see what we got with the integration in. I'm going to take and push that inside, and at the same time, I'm going to pull the 7 outside. So I've got 7, I'm pushing the 12 in, x squared, over, and then I know I've got a 12 outside, and I've got the square root of, my u is this 4x cubed minus 5 dx. Now I definitely see where I have my u and my du, so I can substitute in. So I've got 7/12, the integral of, I'm going to go ahead and write this as a 1/2 power now. And then for the orange, I'm substituting in u. For the blue part, I'm substituting in du, and my numerator is just a 1 because I've substituted in for that entire numerator. Before I integrate, I need to move this upstairs by making the exponent negative. So we've got 7/12 equals, oh, sorry, not equals, times the integral of u to the negative 1/2 du. I'm going to add 1. So we have 7/12. Oops, get rid of the integral symbol, and that does not look like a 12. Okay. U to the 1/2 divided 1/2 or multiplied by 2 plus c. 2 goes into 12 6 times, so we've got 7/6 times the square root of u plus c. We're going to go ahead and substitute our u back in, so I'm substituting in the 4x cubed minus 5.